In this video, we're gonna use the thing that we have been studying about the increasing, decreasing, concave up, concave down, and asymptote in order to graph the function. So I'm gonna teach you about 6 examples, how to gathering information, and we're gonna be able to have a curve sketching of the given function. So the first thing that we have is example 1. You have fx equal to x times x minus 4 to the third. And we're gonna gathering information first. The first one asks you about the domain of the function f. So in this case, you see that this thing turned out to be just polynomial. So the domain turned out to be any real number. And the way that we gonna write down any real number turned out to be just negative infinity to infinity. And you're gonna have x-intercept and y-intercept. In order to find x-intercept, you're gonna put y equal to 0. So when you put y equal to 0 in this function, you're gonna get x equal to, so it's gonna be 0 equal to x times x minus 4 to the third. So you have x equal to 0 and 4. And the next one is going to be y-intercept. Y-intercept, you're going to put x equal to 0. So you get y equal to f0 equal to 0. And the horizontal asymptote, you see that if you find the limit x go to infinity, limit x go to negative infinity, this one will be does not exist. So in this case, it's going to be none for this one. So you not have vertical horizontal asymptote. And for vertical asymptote, it's going to be, in this case, you have no denominator. So you have also none for the vertical asymptote. And the next one, you're gonna find derivative. So the question asks you to find the first and the second derivative of this function. So you're gonna have f prime x equal to the first derivative of the second plus the second derivative of the first. So you're gonna multiply with 1. So in this case, you're gonna have x minus 4 square, and you're gonna have 3x, okay, plus x minus 4. Okay, so this thing turned out to be x minus 4 square, and you have 4x minus 4. So you get 4x minus 1, okay, times x minus 4 square. And the next one is you gonna find f double prime. For f double prime, you're gonna differentiate for x minus 1, x minus 4 square. So it's gonna be the first derivative of the second, 2 times x minus 4, okay, plus the second, so you get x minus 4 square, and derivative of the first, you get 1. So you would have 4x minus 4 that you'll be able to pull out, and you get 2x minus 2 plus x minus 4. So you will get 4 x minus 4, and you have 3x minus 6. So you will be getting 12, x minus 4, x minus 2. Okay, so this is how we have the first and the second derivative. So we're going to find the critical numbers in the next question. The next question asks you about the critical numbers. So you're going to let a prime equal to 0. So you get x equal to 1 and 4. Okay, so you're going to have x equal to 1 and 4 are critical numbers. And you're going to do about increasing, decreasing. So for increasing, you're gonna draw a sign test for f prime. So this guy, you see that you have a line and you do the sign test. So it's gonna be 1, 4, and you're gonna have psi of f prime. Okay, for psi of f prime, you're gonna put the numbers in each interval. So you see that in this interval, you're gonna have x equal to 5. And if you plug in x equal to 5, so you see that it's gonna be positive, and this guy always positive. So it's gonna give you the positive side in the first interval. So you have positive side. And for the second interval, you're gonna pick x equal to 2 in this case. When you have x equal to 2, so you're gonna get to 2. This guy always positive, so it's gonna be also positive. And the last one, you're gonna put x equal to 0. So you see that it's gonna be negative for this term. So it's gonna be negative. So you have the sign negative, positive, and positive. So for this one, if you draw an arrow, so you see that this guy will be going down, and this guy will be going up, and this guy will be going up. Okay, so you see that you have x equal to 1 will be minimum in this case, and you have nothing at 4, it's going to come up, so it's not going to give you maximum or minimum. So it's going to be increasing on negative infinity up to 1, and it's going to be decreasing on 1 to 4 and 4 to infinity. The next one is about the local maximum and the local minimum. For the local maximum, you see that you have none in this case. Okay, so you have none for local maximum. And for local minimum, it's gonna turn out to be at 1. So it's gonna be at the point 1, F1. Okay, so you're gonna just compute F1. F1, you're gonna plug in 1 into the original function. So you need F1, so you're gonna plug 1 here, and you're gonna see that this guy is turned out to be 1 and negative 27. Okay, so you have 1 negative 27 for relative minimum. And the next thing is gonna ask you about concave up, concave down. So in this one, you're gonna draw another sign test for f double prime. So this one, you're gonna check the sign of the second derivative. Okay. So for the sign of second derivative, okay, you're gonna have x equal to 2 and x equal to 4. So you get 2, 4, okay? And why do I have 2 and 4? Because I letting this guy equal to 0. And you see that you have x equal to 2 and x equal to 4 to test the sign, okay? So you get, let me use other color to not confusing you. So this one, you get x equal to 2 and x equal to 4. You're gonna plug in something more than 4. So it's gonna be 5 and 5. So you see that it's gonna be positive in this interval. And for this second interval, you're gonna put x equal to 3. So it's gonna be 3 and 3. So in this interval, okay, so you get negative, positive. So it's gonna be negative. And for 2, it's gonna be x equal to 0. You plug in x equal to 0. So you see that it's gonna be negative times negative. So it's gonna be positive. Okay. So in this case, you're gonna answer concave upward on negative infinity to 2 and 4 to infinity. And for the second interval, it's gonna be 2 to 4. Okay. And you're gonna see that this one will be concave up, and this one will be concave down, and this guy will be concave up. Let me write on here, up, down, up. So you will get two inflection points, which are 2 and 4. Okay, so you have two inflection points. So in this case, it's gonna be 2F2. So it's gonna be 2 and F2 you plug into the original function. So it's gonna give you negative 16. And another point will be 4F4, and it's going to become 40. Okay, so in this one, you get this information that you have. So you're going to use this information in order to sketch the curve of the function f. So I'm going to first draw the x-axis and the y-axis. Okay, so you have this one and you have this one. It's gonna be kind of, so you have y and you have x, okay? And the point that you're gonna plot will be the point that you have seen in the calculation above. So you see that you're gonna plug in the x-intercept and y-intercept, okay? So the first thing will be for x-intercept and y-intercept. So you're gonna have 0, 0, okay? And it's gonna be 4, 0. So you need 4, right? So it's gonna be 1, 2, 3, 4. Okay. So in this case, it's gonna be 4, 0. Okay, I plot them. And I also have to plot 1, negative 27. So it's gonna be something here, 1, negative 27. Let me draw it down here. Okay, so this guy will be negative 27. So this one is 0, 1, 2, 3, 4. Okay, and this point is negative 27. And the thing that you also need will be 2, negative 16. Let's say somewhere here. Okay, so we have all the plotting point that we have. Okay, should be good enough. The next one will be, we're gonna put the sign of f prime and f double prime into the x-axis. So you're gonna have psi of f prime and you have psi of f double prime. For psi of f prime, I'm gonna use different color. So for psi of f prime, I'm gonna plug in. So how could I plug in? So you're gonna just copy this guy from here. Okay, so you can copy positive, positive, negative in the corresponding interval. So you're gonna have positive, 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 and you have negative, okay? And you're gonna have positive for the whole thing here. Okay, so this is how we have the sign. I made the mistake here. Sorry. So it's gonna be negative and positive for the middle interval. And the second derivative. So for the sign of the second derivative will be between 2 and 4, it's going to be negative, and this become positive when x more than 4, and when x less than 2, it become positive. Okay. So for this one, this is how we have the sign of a prime. And you're not having horizontal asymptote and vertical asymptote, so we're not gonna put them in. The next one that we're gonna try to determine will be the shape of the graph in each interval. So you see that you're gonna separate this one into maybe you see the sign here. This one is negative, positive, okay, for f prime and f double prime. So this one is negative, positive up until 1. So for this, okay, so you're gonna get positive, negative. So I'm gonna say shape, okay. So you see the shape of the graph in this interval, negative 1 to infinity. The shape turned out to be what is called decreasing concave up, decreasing concave up. In another interval, so it's on 1, 2, you see that it's gonna be positive, positive. Positive, positive is mean you have increasing concave up, okay? Another one, when x between 2 and 4, is gonna be positive, negative. Positive, negative, it will be increasing but concave down. And finally, when x more than 4, it's going to be increasing and concave up. Okay, so the shape of the graph turned out to be decreasing concave up. It's going to look like this shape. Increasing concave up, it's going to look like this shape. Increasing concave down, it's going to look like something like this. Okay, so it's going to be decreasing concave down. This is the shape of the graph that we have learned last lecture. And you have increasing concave up, so it's going to be this shape. So you see that you're going to combine this shape of the graph together with the point that you already plot into the function, and you're gonna like gathering them into one complete graph. So for this one, I'm gonna graph this guy. So you see that it's gonna be increasing, decreasing concave up. So you're gonna graph this one like this. Okay, so this one in this interval is gonna be this shape. And then you have increasing concave up. So it's gonna be like this. And it's gonna be increasing concave down that is gonna be touching, not touching, what is called intersecting for 0. Okay, and it's going to be increasing concave arc like this. Okay, so this one you have the complete of the graph that you are having. Okay, so this one is your y equal to fx, and you see that it's going to be 4 pieces that we gather information from the above guideline, and then you gonna have the graph of the function fx equal to x times x minus 4 to the third. Okay, so this one is the graph that you see. Okay, so and this one will be all for this question. It's gonna take time, okay, in order to gather information and in order to graph the function correctly. Okay, so let's do the next one. For the next one, you have fx equal to x to the 4/3 minus 4x to the 1/3 on the interval -1, 4. So this one is going to be just the function on a given closed interval. So you have fx like this. Before I do the x-intercept and y-intercept, let me put this one in an easier form. So you see that this guy, you have x to the 1/3 and you have x minus 4. Okay, so you will get the x-intercept equal to x equal to, so you have this guy equal to 0 for x-intercept, and you're gonna see that you're gonna solve for x, so x is gonna be 0 and 4. And for y-intercept, it's gonna be, you plug in, so it's gonna be f0 equal to 0. And you have horizontal asymptote and vertical asymptote. They are none, because you're not going to go to infinity in this case, and you're not going to see any denominator in this case. The next question asks you to differentiate. So f prime x, so it's going to be, you're going to use this one, so you don't have to use the product rule. So it's going to be 4/3. Okay, so x to the 1/3 minus 4/3. Okay, x to the -2/3, and you see the second derivative. The second derivative will be 4/9. Okay, and let me change the color a little bit. So it's going to be 4/9. Okay, so you have x to the -2/3. Okay, plus 8/9. Okay, x to the -5/3. So in this one, you're gonna simplify in order to find the critical numbers. So you're gonna be able to pull out the lowest degree. So this one you get 4/3 outside, and you pull out x to the -2/3, and you would have x minus 1. Okay, so you see that this one, if you put it in this form, so it's going to be x minus 1 over x to the 2/3, and this guy equal to 0. So you're gonna be able to solve this one. So you would get x equal to 1, but wait, you see that on the bottom, you have the derivative does not exist at x equal to 0. That will be the candidate for the critical numbers also. So in this case, you're gonna see that it's gonna be x equal to 1 from 0, and you're gonna have another information here that you have x equal to 2/3. Okay, so you have x equal to, not x equal to 2/3, x equal to 0, to be the point that you do not have the derivative. So in this case, you're gonna have two critical number x equal to 1 and 0, and 0 come from the reason that the derivative does not exist. Okay, so this is how we obtain the critical numbers. So you have x equal to 0 and 1. Okay, so that's my critical numbers. For the next one, you're gonna find the point where you have f double prime equal to 0. So in this, the second derivative, you get 49 x to the negative 5 over 3, and you have x minus 2. Sorry, it's x plus 2. Okay, so you gonna get 49 x plus 2 over x to the 5 third. Okay, so for this one, you're gonna see that you're gonna have 2 points again. It's gonna be negative 2 and 0. Okay, so you have x negative 2, 0. The next step will be we're gonna draw a line, and we're gonna have it for the sine of f prime and sine of f double prime. I'm gonna try to squeeze everything down here. So for this one, okay, so I have 0 and 1. Okay, I have 0 and 1 like this. And you gonna see that this one, you're gonna have sine of a prime. So for this one, you're gonna plug in x equal to 2, x equal to 1/2, and x equal to negative 1 in each interval. So in this case, it's gonna be sine of a prime is gonna be positive, and in this interval, for x equal to 1/2, it's gonna be negative, and so it's gonna be negative for this interval also because of the bottom is positive. So on top, when x equal to negative 1, it's going to become negative 2, and on the bottom, it's going to turn out to be square. So it's going to turn out to be positive. So it's going to be negative, negative, and positive. So when you have negative, negative, and positive, so you're going to get decreasing, decreasing, and increasing. Okay. So you're gonna see that you have minimum at x equal to 1. Okay, so you have minimum at x equal to 1, and you have decreasing from negative infinity to 0 and 0 to 1. Sorry, that my increasing. So this one is decreasing. And for increasing, you would get 1 to infinity. Okay, so this is how we have this one. And you're gonna see that you have no local maximum, and you're gonna have the local minimum at 1f1. Okay, so for 1f1, it's gonna be right, 1f1. So in this case, it's gonna be 1, and f1 you're gonna plug here. So it's gonna be 1 minus 4, so it's gonna be negative 3. Okay, so this is how we have this one. And we're gonna try to find absolute maximum and absolute minimum For absolute maximum and absolute minimum, you're gonna compute, okay? So you're gonna compute the value at the critical numbers. So you have to compute F0. So we're gonna compute and compare. Okay, the value at 0, F0, F0 in this case equal to 0, F1, okay, so it's gonna be -3, and if at the endpoints, so the endpoint for this one, the endpoint is gonna be at -1 and 4, and if at 4, so for f at -1 is turned out to be 5, and f4 turned out to be equal to 0. So you have these two guys. Okay, so you have the absolute. So you compute f0, f1, f-1, and f4 in this one. So you're gonna compare, okay, after you compute this one, you're gonna compare these four numbers to see which one is smallest, which one is highest. And you see that you have the smallest one and you have the highest one. Okay, so you're gonna say that this guy will be absolute minimum, and -1 will be absolute maximum. Okay, so for absolute minimum, it's gonna be the way that we're gonna answer will be the value, right? The question asks you the question asks you about the point, so it's gonna be -1 and 5. So I'm gonna answer this guy in this way. So it's gonna be -1 and 5. And for absolute minimum, it's gonna be 1 and -3. Okay. And for concavity up and down, we're gonna go checking the size of f double prime up here. So you have the sign of f double prime, the point that you're gonna plot turn out to be 0 and 4. -2 and 0. However, you see that the thing that we are working is gonna be from x equal to -1 and 4. So we're not gonna go further than -1 and 4. So it's gonna be -1 and 4. And we're gonna check the size only in this interval, -1 and 4. So you're gonna have the size of f double prime. Okay, so this one is gonna be, I have no space here. So it's gonna be f double prime, okay? And you see that here, let me make this one somewhere. I have a lot of space here. Okay, so for this one, you're gonna do the sign of the second derivative. So you see that the second derivative, you're gonna have this interval and this interval to concern. So you have x from 0 to 4, you just pick x equal to 3. So you plug in x equal to 3. So you would get positive sign. Okay, so you would get positive sign. And in 0 to -1, you put x equal to -1/2. Okay, so -1/2. You see that on the bottom, you're gonna get negative sign. So you get negative sign in this interval. Okay, so you see that it's gonna be concave down and it's gonna be concave up. So it's going to be concave up from 0 to 4, and it's going to be concave down on -1 to 0. And you see it's changing from concave up to concave down. So you have one infraction point, which is 0. So you have infraction point 0, 0. Okay. So we have this one. However, you may argue with me a little bit that, hey, what about -2? So this one I'm gonna mention a little bit that -2 is outside the interval -1, 4. So we not concerned, okay? And we're gonna use this guideline in order to sketch the curve of the function f. Okay, so first of all, we're gonna draw the x-axis and y-axis. And you see that it's gonna turn out to be only between -1 and 4. Let us write down -1, 1, 2, 3, 4. So you have -1 and 4, and you're gonna go to 5 and -3. So this is will be your all of the point that you will need. So you have your y, your x. So you're gonna plot the point that we already know. So we know f -1. Okay, so -1. Let me write this one. -1, 0, 1, 2, 3, 4. Okay, and this guy will be -3 and 5. And we're gonna plot -1 to 5, which is our absolute maximum. And we have 0, 0, which is x-intercept and y-intercept. And we have one -3, which is our local minimum that we already computed. And we have x-intercept at 4, 0. Okay, so they are the point that we gather from the above calculation. And we're gonna put the sign of f prime and the sign of f double prime. So for the sign of f prime, as the above calculation tells you, it's going to be positive when x more than 1. And it's going to be negative. And the next one will be positive, will be when x is more than 0. Okay, and it's going to be negative for the rest. Okay, and you have infraction point and local minimum. So this one is local min. Okay, and this one is going to be infraction point. Okay, so this is what we have gathered from the above. The next thing that we're gonna do is gonna be, we're gonna try to shape our graph. So you're gonna see that you're gonna have negative, negative in this interval, negative, positive in this interval, and positive, positive for the rest. So negative, negative become this graph. Okay, so it's going to be decreasing, concave down. So this one is the shape of the graph. And you see negative, positive is going to become here. And it's going to be positive, positive is going to go up. Okay, so you're going to connect the graph together. So for this one, which color? I should use the purple one. So you see that we're gonna connect phi to 0 with the shape that is gonna be decreasing concave down. Okay, and the concavity will change at 0 like this, and you're gonna see that it's gonna be increasing concave up in the last interval. Okay, so this is how we connecting the dot in order to give you a curve. Okay, so this one will be the thing that we have for the graph on the interval -1, 4. Okay, so let me try to make this one sharper. Here, yeah, okay, this one is nicer. Okay, so this one is the graph that you're looking for. It looks like not quite satisfied. Okay, so this one I'm more satisfied because it's not going to be lower than the local minimum. Okay, so this is all of the thing. Okay, so this is 10 that you use the above guideline in order to determine the shape of the graph, and you'll be able to get the all of the thing that you have. Let's do one more. So you have fx equal to 1 over x squared plus 1. And the question asks you to answer the domain. The domain in this case, you see that the bottom guy never 0 because it is x squared plus 1. So this guy is never 0. So you're gonna have so you have x squared plus 1 never equal to 0. So the domain of f turned out to be negative infinity to infinity. So it's going to be any real numbers. And you have the x-intercept. The x-intercept is going to be, you're going to have none because this guy never be equal to 0. Okay, so this guy 1 over 1 plus, not 1 over x squared plus 1 is never equal to 0. So you have none for x-intercept. So for y-intercept, you have f0 equal to 1. Okay. For horizontal asymptote, you need to find limit x go to positive infinity of 1 over x squared plus 1. So you would get 0. Okay, it is 1 over infinity. And you have limit x go to negative infinity. So it's become 0 as well. Okay, so in this case, you're going to have y equal to 0 is your horizontal asymptote. For vertical asymptote, you see that the bottom guy is not equal to 0. So denominator not equal to 0. So it's going to be none in this case. For the next one, it's going to be for f prime. Okay, so for the f prime, you're gonna differentiate this one. In order to differentiate this one, it's gonna be 1 over u. Okay, so you see that this guy is 1 over u. Okay, sorry, maybe 1 over u. So in this case, when you differentiate, you're gonna just have negative 1 over u squared. So negative 1 over u squared. and you're gonna have to differentiate the inside. So when you differentiate the inside, you're gonna multiply by 2x, okay? So in this case, you have f prime x equal to this one, and this one is gonna be negative 2x over x squared plus 1 squared. The second derivative will be using the quotient rule. So this guy will be quotient rule. So it's gonna be the bottom. So you have negative side outside, okay? And you're gonna have the bottom derivative of the top. So it's gonna be the bottom derivative of the top minus the top, which is 2x, derivative of the bottom. So derivative of the bottom is 2x squared plus 1, okay? And you have the bottom square, x squared plus 1 square, and then another square. And so this is what you have. Okay, so you're gonna simplify this one in order to find the critical number and the inflection point. So this one will be equal to, okay, so this one will be equal to, so you see that you'll be able to get rid of x squared plus 1 on the bottom and on top. So you'll be able to get rid of x squared plus 1, okay? So in this case, you would have negative side, okay? So you would have negative side, and it's what? It's gonna be 2 x squared plus 1 left minus 4x, okay? And over x squared plus 1 to the third. Okay, so this one will be the thing that you have, right? Okay, so for this one, it's gonna be 2x. I forgot, sorry, it makes mistake here. Okay, so I forgot to differentiate 2x here. I forgot to differentiate 2x here, okay? And this guy will be 1 plus x squared. Okay, so this guy will be, you get rid of, let me write this thing in the way that you can see easier. So you pull out 1 plus x squared, and you have negative side outside, okay? And you're gonna have 2x squared plus 2, okay, plus 8x squared. Not plus, minus, okay, and gonna be over x squared plus 1 to the fourth. And you see that this will become negative of negative 6x squared plus 2 over x squared plus 1 to the third. And this guy equal to 0, okay? And you're gonna see that you're gonna have x squared equal to 1/3. So you get x equal to positive negative root 1/3. Okay, so that my f double prime let me change the color here a little bit. Okay, so you're gonna find the critical number by plugging in, okay, and by letting this guy equal to 0. So you have this guy equal to 0, and so you get x equal to 0 for your critical numbers. Okay, so you get x equal to 0 for critical numbers. So you have only one critical number. Okay, so you have x equal to 0 in this case. And you're gonna have increasing, decreasing by drawing. So you have 0 in the middle. Okay, so you have 0 in the middle like this. And it's gonna be, you have to check the sign for f prime. Okay, so you have the sign for f prime, and you're gonna get negative for, sorry, it's gonna be positive when x is less than 0, and it's become negative when x is more than 0. Okay, so it's going to be increasing and decreasing. Okay, so it's going to be increasing and decreasing, and in this case it's going to be maximum. So you have increasing on negative infinity to 0 and decreasing on 0 to infinity. Okay, and you have local maximum at 0 f0. So it's going to become 0 1. Okay, so f0 is equal to 1, and you have none for local maximum. Okay, so you have none for local maximum. And the next one is going to be concave up and concave down. So for concave up and concave down, you look at the second derivative. So you're seeing the green guy. So you're gonna draw a real number line, and you see that you're gonna have to plot 2 points. So it's gonna be negative 1 over root 3 and 1 over root 3. And you're gonna check for the sign of the second derivative. So the sign for second derivative will be, so you're gonna plug in x in this interval. So you're gonna plug in x equal to 1. Okay, so when you plug in x equal to 1, it's gonna be concave up, right? So it's gonna be concave up. So it's gonna be positive. Yeah. Another interval, you plug in x equal to 0, it's gonna be negative. And for x equal to negative 1 in the final interval, you're gonna plug in and you're gonna get positive sign also. Okay, so this is how we obtain the sign for f double prime. So you get up, down, and up respectively. So you're gonna answer concave up, negative infinity, up to negative 1 over root 3, and 1 over root 3 to infinity. And you're gonna have concave down. Okay, concave down is gonna be negative 1 over root 3 to 1 over root 3. Okay, and you have 2 infraction point for this one. So you have negative 1 over root 3 and 1 over root 3. So you have 2 infraction point. They are, okay, negative 1 over root 3, and the value for f 1 over root 3 is going to be, you're going to plug into the original function. So you're going to plug in here. So you're going to have 3/4 and negative 1 over root 3, and you're going to have another point which is positive 1 over root 3. You also get 3/4. Okay, and you're going to use the above guideline to sketch the curve of f. So in this case, you're going to draw the x-axis and y-axis. So let me draw the x-axis, and you have the y-axis. So you have y, you have x, okay? And you're gonna see that, you need to plot 1 somewhere here. This is my 1. Let me make this one higher because I also need 3/4. I also need 1 and 3/4. 1 here, 3/4 here, okay? And also you will need 1 over root 3 and negative 1 over root 3, which is about 0 point something. Okay, so it's going to be negative 1 over root 3 and 1 over root 3. Okay, and you have 0 in the middle for sure. So you're going to plot the point that you know, so it's going to be maximum that you have. So it's going to be at 0, 1. Okay, so it's going to be at 0, 1. And you have this guy is going to be at 3/4. And for negative 1 over root 3, it's going to be 3/4. Okay. And you're going to gather the psi for f prime. So it's going to become negative. It's become positive in this interval. Okay. And you have f double prime. Okay. So it's become positive, concave up when x more than 1 over root 3, and it's going to become negative between these two guys, and this one is going to be positive. Okay, and you have the negative side. Okay, so you have this one. You see the horizontal asymptote. Okay, I'm going to have to draw horizontal asymptote. So for this one, it's going to be horizontal asymptote. Let me redo this one a little bit. So I should have dotted. Okay, so it's going to be dotted line. So this one will be horizontal asymptote. Okay, and then you see that this one will be all of the information that we gather from the above calculation. The next thing that we're gonna study is the next thing that we're gonna do is gonna be we're gonna determine the shape of the graph. So let me determine the shape of the graph. So you see that in this interval, you're gonna have increasing and concave up. This one is gonna be increasing, concave down. And this one is going to be decreasing, concave down, and this one is going to be decreasing, concave up. So in this case, you get this picture, increasing, concave down is going to be this picture, and this one will be decreasing, concave down, and for this guy, it's going to be decreasing, concave up. So this one will be this picture. So you see, you're gonna like a plot by like a connecting everything that you have here into one graph. So it would be like, ah, so in this case, it's going to be increasing concave up, and you need to go to positive infinity. So you see that it's going to go to positive infinity and negative infinity. So it's going to go to 0. So it's going to go to your horizontal asymptote. And you see that this one going to pass here. Okay. Let me move this point a little bit. Let me move my one up a little bit in order to make this one nicer. Okay, so my one is here. So in this case, you're gonna connect these 2 points with this curve. Okay, and you're gonna have to draw another one like this. Okay, so it's gonna be, let me erase this one. Like this. Okay, and finally, you get the next one like this. Okay, it's going to be symmetry with respect to the y-axis because of when you plug in negative x into the function, you see that if negative x equal to 1 over negative x squared plus 1, so it is equal to 1 over x squared plus 1 equal to fx. So you get symmetry with respect to the y-axis. Okay, so this is how we, so the shape of the graph will be the same on the left and on the right side. Okay, because of when you plug in the negative number, it's turned out to be equal to the thing that you have for the positive number. Okay, so I'm gonna break you here a little bit and we're gonna do another 3 more in the next video. Okay, so that is gonna be another video for curve sketching.